Good morning, everybody. I'm Erik Österlund. I'm the chairman of the National Swedish Standardization Committee for Ventilation, but that's only a part of my job. It's actually, I'm at the Business Association for Sweden's indoor air quality industry, we like to call it, the ventilation suppliers and the contractors. And our more than 100 member companies, they employ approximately 10,000 people in Sweden and abroad, mainly in Europe. First of all, I'd like to tell you about the Ductwork Airtightness standards, and many of the previous presenters have also told you about them, but the main standard used in our country, in Sweden, is EN 12237 for circular ductwork and EN 1507 for rectangular ductwork. And all of these give us a leakage factor. It's the leakage per envelope area in liters per second and square meter. And that's the key number that you need to come up to, or come down to, actually. The old leakage classification, because it has been ABC for many, A, B, C, and D for many years now, it's quite awkward because Class A is not the best one. And I like to point out what Frank told you before he got a question on this, and my personal opinion is that Class A is rather leaky. It shouldn't be necessary to have it at all, if you ask me. Class B is moderate, and I think it has its given place in this system. Class C is quite demanding, and that has become the normal standard in Sweden. So most of the testing is done to see if you can reach C for the installed ductworks in Sweden. And of course we have the Class D, which is very demanding. Normally our materials that you buy, the different ducts, they are tested for Class D in a laboratory environment, but to actually reach Class D in a real installation, it's very demanding. It's possible, but very demanding, I would say. Just to give you an impression of what is Class C, how much can it leak? So it corresponds approximately to one hole. When you use, for instance, pop rivet, you drill a 3.2 millimeter hole for each pop rivet. So one such hole for each square meter. If you don't have any other leakages at all, you will exactly pass Class D if you have not more than one 3 millimeter hole on each square meter of envelope area in your sheet metal duct. But my title of my presentation is the ARMA. And ARMA means Allmän material och arbetsbeskrivning, and that was Swedish. And translating it, it's a general description of materials and works. And the ARMA, it encompasses all construction disciplines. And one way to explain ARMA is it's a template for inquiries and orders for construction contracts. And as you can see here, you have it, one ARMA for civil works, another one for the building itself, one for electricity installations and one for heating, ventilation, and air conditioning and refrigeration and plumbing. That's in the brown part here. And so there is also another administrative book from ARMA, which has a more overarching role here, how to make different documents and that kind of thing, how to organize things. But the one which we are interested in here, it's the one for ventilation, which is included in this one. Every ARMA is also followed by a RA part, which looks the same, but it's advice and guidance. So the real ARMA part, it's more or less a template for inquiries and orders for construction contracts. And the RA part, the RA, is advice and guidance to the one who is making up the specification. So what's the legal status of ARMA? Has it got any legal status? No, it hasn't got any legal status at all. It's completely voluntary. It's a template for voluntary agreements in the construction business. It's not the law. But it has such established position in our business in Sweden that many actors actually believe that it comes from the authorities. So sometimes we can laugh at people that ask the authorities to change in ARMA because they can't change in ARMA. But it has very strong position. But let's come back to ARMA in a minute. I will have some first remarks on airtightness. What do we need in order to achieve a tight ductwork? We need, of course, the correct material. And do we then get a tight ductwork? Can we be sure? Of course not. It has also to be correctly installed. And then it's tight. But how do you know? Of course, you have to check it. You check and measure, and then you know for sure it's tight. So now we can welcome ARMA back on stage. So ARMA, please tell us how to check new installed ductwork. You can read it in my part Y, checks for air handling systems. Oh, but our new installation is quite big and we're in a hurry. Can we check it all in one single measurement? No, you shall divide your installation in manageable portions. Around 25 square meters, I recommend. 20 square meters is my minimum. Oh, I'm afraid this will take a long time. Is it necessary to test the entire system? Can I just test samples? Yes. I allow samples for brands of ductwork that are officially type approved or third-party certified. The sample size depends on the duct shape. For circular ducts, you shall test 10%. For rectangular ducts, you shall test 20%. However, for other makes of duct, you shall test the whole system. Oh, thanks. I'm lucky. My system is certified, and I can read in the standards how to carry out the testing. Just one more question. What's the test pressure? You shall measure the leakage at the duty pressure of your system, but not lower than 200 Pascal. If you don't know the duty pressure, you shall test it at 400 Pascal. Thank you, Anna. Now I'm ready to start testing. Good luck. Now, be sure never to underestimate the power of an in situ test, and farewell. That was the words of Anna. I have now some more remarks on how airtight are ducts. I often got that question when I used to work with this. And I always say, how much do ducts leak? That's the question to put. And it depends on many things. Airtightness class, of course, pressure, the duct dimension, and the airflow velocity. And I've amused myself by making some calculations. On this graph, you can see the different tightness classes, and also on the y-axis, the leakage as a portion of the total airflow in a duct, actually for 1 meter of duct. So this first example is for a large circular duct. It's a 1,000 millimeter duct and a low pressure, 100 Pascal. And you see here that the leakages are quite low, even for the class A that I personally don't like at all. It's quite low portion that you lose on the way, so to say. So a narrow leaky duct with low velocity, it leaks more, but a wide airtight duct with high velocity leaks less. So you can see it's a very big difference if you take the beneficial case with a large duct on the left here with a low pressure, or if you have a narrow duct with a higher pressure, you get very different percentages. So does this really motivate us to have airtight ducts? 1% of a fraction, does it matter? Well, you could say, as long as you have 1 meter of duct, it's only percentages, but you have many duct runs are much longer than that. So if you have 10 meters, of course, you get much more. And then you realize that the bed tightness class A, then you will lose a quite large portion of your treated air. Let's come back to the classes I showed you before, and how invisible mistakes can ruin the air tightness class. Remember now the permitted leakage, it corresponds to 1 hole of 3 millimeters for each square meter envelope area. And we'll see some examples from reality. This is a corridor in a hospital that was being refurbished. Everything looks fine, but there's a lot of ducts, and it's a quite complicated installation, as you can see. And after some weeks, when I came back, they showed me this and complained, why doesn't why is it so leaky that we have to put mastic on everything? I mean, it doesn't help anyway. It doesn't help to mastic it, but still, we do it, but it doesn't help. A very common mistake then is shown on the next photo here. If you look carefully, you can see here that we have taken out the screw or the rivet. It's one hole here. I hope you can see my arrow. But on the male part here, we have two holes. And the reason for this is that the installer has put the two parts together. He has found that this elbow didn't point the right way. He must adjust the angle. So he takes out the screw and he turns this elbow a few centimeters, and he puts the screw back in the same hole. So it doesn't, one of these holes were invisible, and they are, as you can see, outside of the ceiling here. So that's why systems can leak, and you can easily lose your airtightness class by making invisible mistakes. And here are some other cases of the same kind, where extra invisible holes from screws that were taken out ruins the airtightness class. So my warning for that. And that's actually the end of my presentation, almost. I just want to present you my 3 M's, which can get you the airtight ductwork. You have to choose the right material, you have to mount it correctly, and then, of course, measure. Thanks for listening.